Hello. Hey, how's it going? All right. We have a plan for today. Today's plan is actually a pretty straightforward plan. Check this out. We want to make a system call with our ARM64 assembly. And then we also want to, if we have time, convert an int to string and then have fun. And that's the plan. That was the plan for today. There we go. Increment, automatic. There we go. So while I was getting ready for the stream, I found a sleep.s file, a sleep assembly file, which should work. It compiles, it builds, but we need to implement it right. And then we also want to add it into our loop. And so the idea is what we'll have a loop that prints out something every so often, like maybe once every second. We'll have a loop that prints out something on the screen once every second. I think that's a really good plan for today. Really simple, really streamlined, easy. You would think it would be super straightforward and simple, but before the stream, I was trying to make sure that this sleep file would build. And so it builds, but I don't know if it works very well or not. So we need to be figuring things out here. So the plan is we'll walk through the sleep.s file so we kind of get an idea of what's going on. Maybe we'll pretend we know what's happening, and then we'll call it over here. Yo, MD, hey, good to see you. We are doing assembly today. Cromer, hey, I checked out PubNub yesterday. You did? Really? That's so awesome. And I was blown away by your company. It's a multi-million-dollar. Yes, it is. You're right. We're doing good. We're doing really good. We have 1 billion connected devices. And so we're huge. You would never know. You've used PubNub. There's no doubt. We've touched almost nearly 100% of the IP address space. We not all of it. I can't claim that we've touched all of it, but we've touched a lot of it, and billions of devices. So if you have a Samsung TV, if you've got an Android phone or an iPhone, or you've got a computer, or you've played on an Xbox, anything. Hey, Quantified Quantum. Hey, how's it going? And then Mohammed. Hey, how's it going, guys? Simone. Hey, good to see you. We're going to do assembly today. Assembly day 3. We're going to do some system calls. We're going to get that sleep to work that we never got working last time. We're actually going to get a sleep to work. And then I would like to try to convert an integer to a string so we can print it out. That sounds like it should be really simple. But, you never know about these things. MD, my headphones is not working, so unfortunately you will not be hearing, but you will be seeing. Okay. The subtitles that we have here on the screen should do a pretty good job, since you can't hear, but they don't always get everything right. But it might be good enough. It'll be good enough. Even if you provide services to big products-based companies, yeah, Cromer, we're actually pretty big. So we've got a lot of businesses that use us, and we do communication. We enable communication. It's really so we have it all running in C and in Rust and C, and those are the languages. We also have some Python, we have some Golang, we have some JVM languages. We run in Kubernetes across all of Amazon's availability zones that allow your users to connect to the closest region. So that is, let's see here, PubNub here. Nope, not that one. Here we go, pubnub.com. I can spell it correctly. Can you give me a thumbs up, please? Here you go. There you go. Thumbs up, please. Excellent. Gave you a thumbs up. Oh, whoa. There's a thing that came up here. Hand gestures. Interesting. Yo, Blue. Hey, Blue. Good to see you. Welcome back. We were just chatting on LinkedIn a little bit earlier today, weren't we? Yeah, Pascal, Delphi. We're doing regular assembly. Regular assembly today is the plan. Here we go. Assembly is the plan for today. And we will be trying to do a system call to make it sleep. And then we'll try to convert an integer to a string. Number 2 sounds like it should be easy. Number 1 was hard, but I did get it to build before the stream got started. So not Pascal or Delphi. Caputin, not Delphi, no Pascal. Just at PubNub we have, what are we doing? We do Rust, we do C. We've got some Python. We've got some JVM. Oh, thank you for the likes, you guys. Wow, really shocked and realized you're talking to the CTO. Yep, that's me. You got it. How this works. Like what rights you have. What rights you have. Meaning, can you change anything in the company? Seriously, I don't know these things. For the most part, here's the deal. Yeah, but what I like to do, and it's really important because we have a lot of teams. We have a lot of engineering teams at PubNub, It's very important to give the ownership of the direction, the technology, the improvements to the teams themselves, because it's actually kind of a really cool trick. You got to check this out, you guys. But it's beneficial. It really is the best benefit. It's really the greatest way, because one, it gives them ownership. It gives them the ability to own that decisions that they make and then move forward, and they own the product going forward, and they need to make sure it works. It's a big decision. There's a lot of big decisions to make when you have to power, millions, hundreds of millions of connected devices. There's a lot of critical thinking that you have to do, you guys. Quantified Quantum, is there a board of directors? Yes, there are. It's a big, it used to be small, but it's really big now. We're almost so big that we can't all fit into one room. You wouldn't think, but there's no chairs left. We have to bring in extra chairs. The board is so big. It's crazy. Beneath, hey, what is this? Oh, so we're answering chat questions, but we are doing a assembly day 3. Beneath, the assembly day 3. MD, you've seen in other live. Oh, really? Stephen Freeborn. Mohammed, that's kind of cool. So you guys see each other in different lives. Cromer, so those who don't know and are new to this chat, he is the CTO of a multi-million-dollar company. Yes, that's me. You got it. Isn't that crazy? Yeah. So we do. We connect billions of 1 billion devices, and this is the company here. We're an API company, so we've got all these SDKs here. We've got a lot of SDKs. Let's see here, developers. Here we go. Let's go to developer documentation. And see here, so we got a bunch of SDKs. So you pick your favorite SDK, and then every SDK can talk to all the other SDKs. So if you pick JavaScript, for example, you can communicate with Python, you can communicate with Unity, you can communicate with a REST APIs or C, Rust, of course. You got to have Rust in there. Why not? You have Rust, of course. C# for, and then we've got, Unreal Engine. We run on Xbox, on PlayStation, on Switch, on your phone, on your Android, on your iPhone, your desktops, your Mac, your Linuxes, your Windows, embedded devices. We have IoT SDKs. So that means that now you can communicate. Everything can communicate. Here's the cool part, you guys. Wolves, hey, Wolves, welcome back. Hey, Steven, what's up? We're just walking through some folks who are chatting there, learning about the company, the PubNub company. Yeah, and we're... You guys figured it out. I didn't mention anything, but you figured it all out all by yourselves. You guys are doing some research, aren't you? Aren't you guys? Can you make an AVX12 call? Yes, I can, but only if it's on an Intel processor, basically, or an x86, and embedded in a C++ ASM statement. You can, JB, and that's actually a really good idea. I would love to make an AVX512 call. Wouldn't that be so cool? But I only have an ARM processor. So whoa, PubNub, I didn't know it that they were deeply rooted. Yep, you got it. That's the one. This is it. Yeah, so we cover every platform, every language, all the developer languages, every language, and every console, Game Boys, even the Switches, Nintendos, all of it. You're amazing, man. Thank you, Blue. Appreciate it. We've been doing this for quite a while. We power a lot of things. You've definitely used PubNub and you never even knew it. Isn't it crazy? You would think. So we've got like a billion users. We should be more well known? I would think. Why weren't we well known? But it's because we're behind the scenes infrastructure, right? So we power communication that allows your applications. So like even on chat right now, you're chatting here on YouTube. And that chat, we're communicating over, real-time data information exchange. That is what we do. We power that as well. So appreciate it. Yeah, you guys. Still in shock that I know. Yeah, that you know the company. By the way, I heard PubNub somewhere before while doing research for a project, but he didn't know what it was. Now you know. Now you know. It's so cool. Yeah, I try. So it's one of the things we'll focus on technology, but it won't really brag too much about things or bring certain things up. But it's a lot of fun. If you guys bring it up, I'll definitely talk about it though. I'll talk about it as much as you want. But we do have other topics of the day, of course. How do you get profit? So here, actually, good question. You go to the pricing page. How do we make money? Oh, let's see. Where is our pricing? Here, let's just go to pubnub.com. And so pricing, maybe it's called pricing. Oh, maybe not pricing. Maybe I got to spell pricing the right way. Let me spell it properly for you guys. Here we go. All right, so go to pricing, the correct pricing. And then you pay per user basically. PubNub uses protocol. Yeah, we've got multiple protocols. We use a lot of different protocols at PubNub. And streaming. So data streaming is what we're doing. Data streaming, and it's mostly JSON, but you can, of course, use any data format. We work with any data format. So we make it really easy. You can even upload very large files and send those as well. So it's really powerful. But yeah, this is how we make money. It's on a per user basis. So you pay per user, but it's also free. So we have a generous free plan, basically unlimited free, as long as you're not in production, right? As long as it's not a production app. So you can basically use it forever. You attend the meetings every day in the company. Are all teams handled for you? So I don't, Cromer, good question. I don't go to every meeting because there's too many. There's way too many meetings. So I go to some high level meetings, review meetings, and then meetings that I don't go to from a team, like a sprint review, because we got a lot of different teams. We record all of the sprint reviews, and I go through and I watch those. I watch all of our sprint reviews and get caught up on what each of the teams has progressed on and what they've released. It's a lot of fun. We do Zoom recordings, so we use Zoom and we record all those sessions, and I watch them, and I get up to speed about what's going on. And then we're focusing a lot on artificial intelligence, of course. You know, if everyone's like, the board's like, there's not enough AI. We need more. We need more. Why isn't there enough AI? We need more AI. And so we got to do things like that, of course. So we're focused on that. Is it like a final boss in programming? It's kind of just about, can you give me a small PubNub demo? Yeah. All right. Let's see if we can figure that out, you guys. You're asking the right questions. Let's see if we can figure out. There's tutorial. Let's see if to go to the developer section. I know we've got it in here somewhere. We've got some demos. So developer tutorial. I know it's home. Thank you for the likes, you guys. I appreciate it. See if we can do some demos. Here we go. We got some demos for you guys. Basically, anything's imagined. So the top 10 apps in the App Store today all have built-in app communication. And that's what we power. We power those things. Meaning only the board of directors and CEO meetings, not the normal ones. Yeah, Cromer. Yep. You got it. That's the idea. We do that for sure. I go through most of those meetings. One second, looks like my subtitles kind of got weird. I'm running them over here in this other machine. Oh, they got back to it. Never mind. Like positive. Can you use XSLT? Yes, you can. JB, you can use XSLT files on PubNub. I want to provide XML data with different format options. Yes, you absolutely can. You can totally do it. You can use XSLT, absolutely. You can do it a different way. How is AI used at PubNub? We have multiple AI things happening at PubNub today. Obviously, we're using a lot of the developer tools, right? Claude CLI and Codex and Gemini. We did those things, but we also, where is this? Do we have a blog here? Do we have a blog somewhere? I'm trying to get caught up. There's a lot of demos here. Let's do the demo really quick, and then we'll go down all the chats for all the questions that you guys have, of course. So we'll say Steven. There you go, and I'll log in, and then there's like, oh, thank you for the likes, you guys, appreciate it. So here we go. So there's like a chat, right? So we can do chat. So now if you're on this page as well, you will be able to see my chat messages. That one's like a really easy one. That one's super easy. That's like an easy chat one, but you can also do multiplayer games, right? You can make games and things like that. Let me catch up here. So JB, yeah, we can totally do. So let me see here. There is a PubNub developer console. I think here we go. So you can do anything. So you can send a message and then receive the message. So you can see I've received the message that I've sent, and you can also put anything you want in quotation marks. So like this. Here you go, like that, and say you can put your XSLT here, right, JB? You can put your XSLT there, right here. You can totally do it. Right there, boom, publish a message, and then you can receive it on the other side of the end there. So, but you could also send very large ones too. So if that makes sense. So how Quantified Quantum? How is AI used at PubNub? Good question. Okay, so we've got a lot of different things at PubNub, including AI. And so where is it? So let me see here. Developer tools. Where is it? I know we just released a new product. Let me see on our blog here. Let me see. Go to our blog. I'm pretty sure we announced it here somewhere. AI coding lessons, best practices, AI moderation. So like here's a really good one. Here's a really easy one. So use large language models and some other kinds of BERT models for moderation, right? Some simple moderation, things like that. So AI chat moderation, that's a good one. That's an easy one, but we're working on a lot more for AI technologies, of course. Hey, how's it going? I heard from the grapevine that SpongeBob clapped your cheeks. Okay, then. Nargis, hey, how's it going, Nargis? Good to see you. How old are you, Steven? We don't answer age questions here. These are revealing, but you guys have figured out a lot of things already, and things that I haven't mentioned, but you figured them out. I don't know how you guys figured them out, but that information you probably could also figure out too. And when and how did you start the company? The company started in 2010 on an airplane on a laptop. I was typing on my keyboard, making a message bus infrastructure that can communicate and connect to millions of devices without having any latency. And that was like the main thing. So, there's a lot of communication that occurs with your phone. If you've ever, called someone on your phone, that takes a long time to ring the other person's phone, which is it's a long latency. It's multiple seconds because they have a lot of phones connected. But my technology, I have patents. I have a bunch of patents. So you go to LinkedIn and go Steven Blum. And then we'll see here. Check this out, you guys. So here's me. I've got these patents here that are, here we go. I've got multiple patents. Show all the patents. These patents are for distributing a communication for connecting devices in really excellent latencies, even under heavily restricted networking environments. And so we do a really good job for broadcasting and one-to-one, and we've got some really cool technologies written in C and in Rust, you guys. Isn't it cool? So I started the company on the plane. Yep. So how many ideas have you? Don't resources. And I just started my career as a senior data scientist. Wait, let me read that again. Meaning if you wanted to know how have so many ideas, you have so many ideas, but you don't have the resources. You have the resources. Cromer, you have the resources. You have a computer or a phone. You can type into it, and then you can build the software, and you're good to go. You can make it happen. There's a lot of free like compute options that are available, like Cloudflare, GitHub, even PubNub. We have some free compute available to you. So if that gives you the answer to that question, just do it. You have to do it. You have to move forward. You have to start somewhere, and you have to make it happen. It just has to go. All right, let's see here. Let me go. Does he realize he's just read the same comment like he's not seen them before? I do that sometimes, AA. I do that. Yeah, I do that sometimes. You're totally right. Is the chat moderation multimodal? It is. Yeah, it is multimodal. We are using multiple models and languages. So it's supported from that perspective. I suppose quantified quantum. But yeah. Mohammed, I'm curious, what is the main difference between PubNub and Firebase for real-time messaging? So Firebase is like a database. Firebase is a database where you store your users' data, and then changes happen in the database, get transmitted. PubNub is just the message bus. So we've optimized, but we have a lot more than just the message bus. We have unlimited channels. We don't charge you per channel, so you can have unlimited number of channels to transmit the data. Then you can also filter the data with an advanced filter expressions. Filter expressions, PubNub. Here we go. So there's a lot of subscribe filter details. Here you go. And so you can do wildcard filtering, equivalencies, likes and contains, and or operators. Arithmetic. Look at that. I didn't even think you can do arithmetic. Isn't that cool? So yeah, we're a message bus, but our message is extreme low latency. And we're globally distributed across all of Amazon's availability zones, which means that your users connect to the closest region. Yeah. Let me see. So I hope that answers Mohammed, I hope it answers your question about the difference there. Okay, so JB, what do you have not links in the patents? Oh, I do have links in patents. So check it out. So the links, see the patent. They go to, so for example, here, this is the Google patent number 11,322,538. Look at that right there. Yeah, look at that. That's the patent right there. So you can find me on Google Patents as well. That's where the links go. Chat moderation, meaning providing security to AI agents, and it goes beyond that as well, to actual real users who are chatting as well. So like how YouTube has built-in moderation for the chat that we see here, for the chat. it will. We do the same thing. So we're making more AI technology available as we go. Bless you guys. Sending nothing but love. Thank you. Keep being smart, AA. All right, appreciate it. Blue, you've consistently been blowing your mind since yesterday. All right, that's great to hear. Thank you. Appreciate it. Cromor, what codes back in 2010 might be somewhere in servers till date? Yeah, it is. It's still there. The code from was almost 15 years ago, right? It was 2010. 15 years ago, the code, some code lines are still there in production right now. I wrote some pretty prevalent event-driven C that I wrote on a networking layer that uses epoll in Linux for a kernel call to do high concurrency. And back then, that was pretty groundbreaking. Mostly only things like Memcached and Redis used similar techniques. I took those concepts and I turned them into a messaging bus that was really fast, and no one can beat our performance. And I've got patents for it. There, that makes sense. So yeah, you're totally right, Cromer. Iki, hey, what is this? Oh, people were figuring out what I actually do. You guys figured it out. I never told you, but you figured it out. So there are questions arising. You guys are asking questions suddenly because you're trying to figure. You learn certain things, and then you have questions, of course. And so I'm happy to answer them, but only if you ask the right questions. But I'll definitely answer them. All right. So, Quantified Quantum. All right. Be going now. Got to focus on your business development. Yeah, you do. There you go. That's the plan. B. Hey, how's it going, B? UKY writing something in assembly. Yes, we are. That's the goal for today. We want to do a system call to sleep, and then we want to convert an integer into a string. And number one sounds more difficult, but it is a continuation from the previous day, and I wanted to finish it. Yeah, so PubNub, Mohammed, okay. Mohammed, so PubNub basically takes care of the heavy lifting for real-time communication. You got it. So one of the challenges with real-time communication is the durability of the network connection. Your phone will go to sleep, right? It'll go to sleep. But when you bring it back online, you want to be able to receive all the messages that were sent while you're offline. We have a store and forward technology that we've built into our patents and our communication and our infrastructure. And it will automatically redeliver messages that you missed. And we also gzip the payload, so it's really performant on the receive side, on the download, which makes it, transmit data more quickly. So your end users get your data more quickly, yeah. And then you can have stream and gzipped encoding. We do streaming compressed JSON. Isn't that cool? It's real. I thought it was really cool. I still think it's really cool, even 15 years later. Cromer, JB, you solved a problem that doesn't exist. I know, yeah. Oh, Not Owen. Hey, Not Owen. Good to see you. Let's see here. I looked at the 5 to 6 patents to make sure I understand PubNub's core functionality. This guy is real deal. Yeah, thank you. Yep, it's real. It happened. It took a few years, a decade and a half. And then, those patents take a while to get through. But it's legit. It's legit. It's real stuff. It's real technology. Real technology in production today, powering 1 billion connected devices. And if you were curious about how many messages we send, it's over 4 trillion messages per month. It's a lot. That's a lot of JSON. That's like 20 to 30 petabytes worth of JSON. It's like, a ton of data. It's amazing. Cromer, please pin the comment. Those who don't know, he owns the PubNub, a multi-million-dollar company. Yeah, you got it, Cromer. You guys figured it out. I didn't say anything, but you figured it out. And think doing YouTube Live is your hobby. Yep, you got it. Cromer, you figured it out. YouTube Live is a hobby now. It is for fun, and we're doing it 5 days a week, one for an hour or two per day, and it has to go around my meeting schedule because I got a lot of meetings. What architecture? We're doing ARM64, Matthias. Matthias, good question. ARM64 is the assembly today. That's the architecture. Let me show you the build file really quick. WS, here we go. Look, the build file. Here's the build SH. There you go. Architecture, ARM64. There you guys go. And we also, we're running some ARM processors, but I want to run more ARM in our infrastructure. Thank you for the likes, you guys. Appreciate it. Matthias, nice. Yeah. So that's the plan. Oh, AA, just before I leave, I wondered if you knew any AI platforms that would assist with app development. Probably the best one is Jules, or see, it depends. AA, it depends. This depends. So we've got Jules.Google, which I like a lot. I think this one's a really good one. You should consider Jules.Google. But if you are less technical and you want just the high level, I think it's called Lovable AI. And then the other one is Replit AI, right? So low code AI platform. And then the other one is Lovable. Here you go. The other one is Lovable. Or where is it? Vast AI. Oh, nope, not that one. Where'd it go? Where it is Lovable? There it is. Okay. So these are the two that I've heard of. So Replit or not Retool. I sent a picture to Retool. It needs to be Replit. I think it's in there. Here you go. Replit. Here you go. There you go. Let's go. Yep. Less technical indeed. Okay. So probably Lovable is a good user experience for less technical, and Replit is another good one. Yeah, there you guys go. I hope that answers. Hey, Ben Creations. Hey, how's it going? Happy to have you here. Shyam, hey, Steven, how are you today? I'm doing good. Thank you. I'm really excited. We are going to be doing some assembly today. ARM64. Love you, guy. Thanks. AA, appreciate it. Can you show us your GitHub, Cromer? Yeah, let's show you the GitHub. GitHub.com, Stephen LB. This is probably safe. I'm going to show you that. There you go. You can see my GitHub. Here you guys go. You can see, I still code some, so you can see here. Look at the contributions in code. You can see I code here a little bit. And then I moved to Seattle in January and February, so I had less code there. That's why there's less code in January and February, if that makes sense. All right, see here. Let me catch up with some of the chat messages, you guys. Let me see. What is the largest message size PubNub supports? JB, we support basically an unlimited message size, but that is with an asterisk. That's with an asterisk. So the JSON or XSLT, the JSON payload that you can send is 32 kilobytes. However, we have a large message API, a very large message API that lets you do megabytes, and it's called our Files API, but it's the same thing. It's essentially the same thing, but it requires a few extra steps. So you can send very small bits of JSON or XSLT or any kind of data that you want, up to 32 kilobytes or 32,000 characters, or you can send millions of characters with our Files API, which is just one step further because it does a few extra checks because it's larger data. And so we want to make sure that all that data gets to the end target. So our Files API is the same. It's just a little few extra steps, if that answers. So millions is the answer. We figured it out. If you're trying to do a really big message, you can do it. We support it. Millions is the answer. All right, here, getting caught up with some of the chats there. Let's see. Blue, how easier is it to code something which is close to system level in assembly as opposed to other low level languages like Rust and C? Okay, Blue, assembly is super challenging, right? Assembly is just insane because it's just so verbose. Appreciate the likes, you guys. Thank you. You can see the heart messages flow up there on the screen. Yeah, it's insane. Yeah, woohoo, all those heart messages. I love seeing it. I can see it when it shows up there on the screen. So let's see. Wait. Let me jump back here. I kind of got lost. Okay, yeah. So Blue, C and Rust are way easier. But that C and Rust is so much easier. I appreciate it. Appreciate the likes, you guys. Yeah, see, you can see the little heart thing, kind of throw them up there on the screen. You can see it. That's what I see when you do that. I can see them happening. They're all like animating right now. That's really cool. Yeah, so like C and Rust, like C is just so much easier compared to assembly, you guys. It's so much easier. And I can tell you that learning assembly, though, is a lot of fun. Thank you for the likes, you guys. Appreciate it. It's you look all sorts of different likes in there. We got all the party poppers, the 100s, the hearts. That is really cool. I like to see that. It also like that's where my focus goes. Right when you do that, I focus. Like it's here on my screen, but it's up there for you. I can see it. I can see it happening. It's a lot of fun, and it definitely focuses me on when you like. That's where my eyes go, and like I lose a little bit of chat. So, Blue, I hope that answers your question. Rust and C are way easier than assembly by far. B. The letter B. I'm a junior dev, feeling insignificant. Don't worry. It's always hard. Don't feel insignificant. You just got to keep going. Don't stop. Just keep going. Just keep going is the answer. Keep going. It's always a challenge. I have challenges even after all the experience that I've run into. I make mistakes all the time, and you just have to keep moving forward. That's what it is. It's all about that discipline and motivation. You just got to keep going, and you'll make progress, and you'll pay off. It'll get paid off with the rewards. Cromer, you use Replit a lot when you were learning Python for the first time. Cool. Excellent. That's a great language, and using Replit to help you with that for sure. Okay, logging off. Have a lovely weekend. Excellent. Cool. AA, thank you for being here. I missed your message a little bit earlier. I'm trying to catch up on all the chats. Very cool. GitHub. Shyam, thank you. Shyam, appreciate it. Absolutely, yeah. Been doing it for a while. Joel, I need an ML platform for image recognition at high speeds. Any suggestion? Joel, yes. All right, so let's pop over here. Go PyTorch. Just a vision transformer. Do this. I would say is the VIT, vision transformer. Do a vision transformer with PyTorch. This will be the fastest and the most modern approach to computer vision. If you want to be at the forefront of AI and computer vision, do a vision transformer. And that is the answer. There you go. I hope that gives you the best possible answer for today in 2025. Beautiful, organized GitHub. Excellent. Thank you. Subject of AI. Appreciate it. Sion, if you organize assembly into subroutines and functions, it can become abstract as you want. Yeah, so that's what I started to do. I started to do that, you guys. That's exactly what I started to do because it was getting too complicated. It was getting a little complicated for me. Let me see. Okay, so getting caught up with some of the chat messages here, you guys. Let's see. You can make it easy. Yep. Is assembly hard to learn? Yes, it is. I was struggling. I'm like, what happens if you do this? So it's mostly just a bunch of trial and error. So that's what we're going to do. That's the plan for today. We're going to get through some of the chats. I get through some of the chats, and then we're going to do these things here. These are the goals. These are the goals for today's stream, you guys. Hey, M7 Stick Eclipse. Good to see you. Happy you're here. Steven, I have to learn Rust. You learned Rust and made a few CLI apps. Cool. Excellent. Shyam, that's really great to hear. But what should I focus on Rust going beyond? Okay, so I have a recommendation for you. Beyond lifetimes, here's lifetime annotations. I say in Rust are they're things that I don't want to ever have to deal with. Here's the deal, Shyam. Here's the deal. In Rust, if you are dealing with lifetimes, you're probably doing it wrong. That's the way I see it. If you're dealing with lifetime annotations, that means that you're doing it wrong. You can build Rust code and never touch lifetime annotations. You could do it. And that's what I recommend. I absolutely recommend doing it. Just do not use lifetimes because other than maybe like a static const that exists that is available for multi-read and multi-core scenarios for concurrency, you don't need to use lifetimes anything other than like a static forever lived item in Rust. Okay, I hope that answers your question. But guess what? Focus on, I would say, something like Axum Rust. That's a good one. Tokyo Axum Rust is another good one. I would say this is probably a good place to jump into next because it's like the next level up. It lets you build a web server. Seeking the divine mystery. Hey, good to see you. Happy to have you here. Enter the username here. Enter username here. Favorite brand of coffee. I believe it was Stumptown. Here we go. Stumptown coffee. That's the favorite brand of coffee for you guys. Absolutely. Let me click the reset button here one second. All right. There we go. All right. Is it working now? Better. Got to sometimes click the restart button on that. Okay, I watch these lives without understanding anything, but I hope you have a great day. I can reach at that point. So wait. Let me read that. Sai, hey, how's it going? Happy to have you here. So you watch these lives without understanding anything, but you have hope. One day you can reach that point. Here, that's the deal. Every day you make a little bit of progress. Keep going. Keep moving forward. It's just a continuous. It's a challenge every day, but you just do one thing that day and you're good. Just learn. You're good to go. Cromer, or use YOLO for image recognition. Oh, YOLO. Yeah. So there is a YOLO image. It's an image. It's like a easier. It's a pre-trained model. It's pre-trained. So it's a YOLO pre-trained vision model. Probably not that, but let's go to it really quick. Where is the YOLO project? It's called Ultralytics. Ultralytics, you guys. Ultralytics. So here you go. Ultralytics. If you want to do object detection, you can use YOLO. Is that cool? It's pre-trained and built for you. I think you have to do a little bit of transfer learning or some fine tuning, but it's still a better place to start. YOLO is the answer. That's that. Who recommended that? Who recommended YOLO? Cromer. Great recommendation, Cromer. Thank you. Thank you for recommending that. That was great. Good advice. Esteban, MATLAB, Simulink, best ones. Those are pretty good. Those are pretty good languages, I would say, for sure. B, how do you improve your skill? Many say that always building projects, which I do, but I feel like without learning the theory, it's just copying tutorials. Here's the deal, B. It's okay. You don't need to know the theory. You don't need to know the science behind it, because what you need is the ability to achieve goals. And that's how I started. I didn't necessarily know, actually, I didn't know really what the science was or the objectives or any of how the theory works or the algorithms. I just knew if you type this code in this pattern into an editor and then you saved it and you compiled it, it would build a working application. That's all. That's it. So you're just working with text. You don't really need to know so much about the theory behind it, but just moving forward, and that is like the best way, I would say. Just make that happen. That's it. You don't need it, but it is fun sometimes to learn a theory, for sure. It is fun, and it does help. Don't get me wrong. It does help to know the theory. Okay, here you guys. All right, almost got up with the chats here. Ayush, hey, how's it going? Happy to see you. Thanks, Stephen Shyam. I will focus on Tokyo Axum and more crates, which are popular, and build apps. Cool. That's actually a really good next step. So we use Axum at PubNub to power some of our infrastructure, and it works to power some of our REST APIs. Cromer, okay, I'm finally caught up with all the chats. Now we'll be able to actually do some assembly work, you guys. We'll actually be working on assembly next now. So Cromer has some information for B here, but it builds ideas. Yep, you build ideas, build workflows, and how that works. That's the learning part. It is. Copying tutorials is okay, but you learn how it works. You can implement that in various things later. You totally can. Hey, Rajnish, happy to have you here. Okay, you guys, we are finally caught up with all the chat messages. That was a lot of chat messages again about today. Here we go. Okay, so let's do the system call on sleep. Here's the goal for today. So we've got this sleep file over here, sleep.s, and it's so text represents the code. This is the start of the code, right? So we know that. We learned that start of code section. Yep, the start of code section. You got it. Align to tells the bits, right? So we're going to do align to 4-byte boundary. And then this is a function call, I think. This is the function call. So we've got something called underscore sleep and s. So sleep nanoseconds. This is like a function call. So if it's defining a function. So in this case, it's kind of like this in C, but also maybe it's like function. And so JS would look like this. It would be like a function underscore sleep. Here you go. So it'd be kind of like this. And then in Python, it would be like def, right? Def sleep nanoseconds, like that. Here we go. Let's close that so we get the screen a little bit easier to see. And then in Java, it would look like this. Here, there you go. And that's what this is here. That's kind of what that is right there. Blueprints and Lord. Hey, happy to see you here. Welcome in. Thank you for the chat message there and the icons. All right, here we go. Emoticons. So we've got our function here. And then we've got a whole bunch of stuff that I don't know what's going on. I don't know what this is. We're just talking about copying, pasting code. Guess what? Guess what happened here, you guys? There's some copying. Can you declare a structure? Yes, you can. You can declare a structure in assembly, sort of, by using a variable. So you see, I think, so declare a structure in ASM like this. You totally can. This, here you go. And it would be like, I think you have to do, I don't know if you can do .type. I actually don't know what's going on here. I don't know what that is. But I know we did it the other day. I know we made it. Blueprints and Lord. Yep. Thank you. Absolutely. Here we go. So it doesn't look exactly the same as like a C struct, but it does look something like a dot, I think it was a dot align 3, and then you could define a variable like time, colon, and then something like this, and then you can also do another one like this. So you can do this. So let's do how do you do a number? I forgot how to do a number. How do you do a number? I don't remember. Do we have any examples here? But basically the idea is that you just basically stick everything, multiple data chunks into the same variable name is what the idea is. So you kind of like this. So like say you've got, or it's a quad, that's what it is, quad. Quad is the answer. Quad 8, and then you do, so you could do something like this. So like this is a struct 3, basically. This is a struct with 3 elements in it. And then you say align, we can maybe align 4, I don't know. Things like that. So this is kind of like a struct in assembly, if that answers your question. XS, a bit off topic, but what is a good framework for creating multi-platform desktop apps? Tauri, you got it, Tauri. It's called Tauri. Tauri is the best one. Tauri is the best one by far. Why? Why is the best? Because it's written in Rust, and it lets you target all the platforms, every platform. What is the list of platforms? There is, I wonder if it's interesting. So we can do, I know it says Android, iPhone, desktop, those sorts of things. So if you wanted to go beyond, desktop apps and into mobile space, you can use Tauri as well for that. And so that's why I recommend Tauri. It's going to be the fastest, it's going to be the most stable, and it's going to be nice. So for example, like Slack and Discord, I believe use Electron. I believe they use Electron, but they have performance considerations. They're a little bit resource intensive, and they can be a little bit slow if you don't have enough resources. So Tauri is the next generation of Electron. It's the next level. Use Tauri for your desktop multi-platform applications. Cromer, I will apply for data scientist at PubNub. You take my interview, and I'm just kidding. Okay, absolutely. So we do have a role. So PubNub careers. We do have. I do believe. Let's see here. Here we go. I know we have an AI role. Here we go. Engineering. So we got a couple engineering roles that we do have open. So they really are there. We see AI engineer and a site reliability engineer. That's currently the openings from engineers' perspective. That is what we currently have open, you guys. So Cromer, how do you feel about being owner of multi-billion? Cromer, here's the deal. You asked the right question. It can be, it's rewarding, but it's also challenging because here's what happens. You've achieved success, but you want to keep achieving success. And it becomes kind of like, maybe like a challenge, a motivational challenge, just to, feel like you can keep doing that because you've done it before. Why can't you do it again? Right? Why can't you just keep doing it over and over? And so there's like this pressure. It feels like there's this pressure to continue to succeed. And it's hard, and you can feel the weight. You can feel the weight of the pressure of the expectation for success, and it is hard. I tell you, it's challenging. And you have your own personal goals and motivation for continuing to succeed. And you could be at the point where you've achieved greatness, but then other things come up that get more exciting, that overshadow some of your technologies and techniques, and then it could be kind of a, what do you call it? Like I guess kind of like a letdown, or like you would say it's kind of demotivating, right? It would be like, oh no, we were in the limelight earlier on, and it was so cool because we were like, we brought this amazing technology to the world, and then all of a sudden AI comes out, and it like, poof, AI takes off, and now that's the most popular thing in the world, and it's humbling at the same time, but you know what? We're gonna keep trying, continue to go, always push forward, move forward, build, and continue to succeed. I think, what expensive car do you own? Hey, guess what? I don't own a car. I do that on purpose because cars require consideration. I'm actually pretty frugal. I don't actually like to spend money, but I don't own a car because I think that's a luxury that isn't necessary. So I do a lot of walking, and I press the order button on the phone sometimes, that sort of thing. But I purposely and intentionally do not have a car. So I have no car. Isn't that weird, Cromer? You'd be like, there's no way. Why would he not have a car? No, I really don't have a car. It sounds weird. I know. The Seal, boss, how you deal with burnout? You have to push through it. You had to push through it, the seal, because it's tough in this world today. In order to win, you do have to be the fastest. So just calling like NASCAR. There's a quote in NASCAR, which is a car racing. Speaking about cars in NASCAR, the way to win. There's a phrase. What was it? In order to win, you have to go faster to the point where you're almost crashing. So you're talking about burnout, the seal. NASCAR, the winners have to go so fast that they're right on the verge of crashing and losing control of the car because they're going so fast. And they have to keep going that fast in order to win. You guys, that is what, I mean, you don't have to go all the way like that, but if you approach that, you're going to be successful. Just to let you know, you can do that, and people do, and it happens. Like your mindset, appreciate it. Absolutely, XS. It's all about just continuing to move forward. Keep going. Don't stop. It's always going to be a challenge, and just expect the challenge. It's actually one of the greatest human technologies that we have today is your ability to recognize mistakes and failure. When you have that, you know how to do better. And you recognize that better. And it's probably way better to do that because you'll learn. It's sort of like what we're doing with assembly here. We're trying it out. We're pushing the barriers. We're seeing what works. We're seeing what doesn't work. Because when you do it that way, you see what fails. Your brain is predispositioned for a negativity bias, which sounds like it's a bad thing, doesn't it? Negativity bias? Doesn't that sound like it's a bad thing? It's actually one of your best technologies that your brain has. You can recognize what doesn't work, and then you can push forward and make it work. And you can find what succeeds, and you will learn what doesn't work, and you will remember that, and it makes you better at what you're doing. Isn't that cool? That's one of the coolest things that you can do as a human. All right, B, let me catch up with some of the messages here. Why is the market harsh on us juniors? I know AI is doing some tasks, but aren't we good investments to become the future seniors? Or is there, okay, here's the idea, B. You are the future, you are the right investment, but the problem is the people at the top. The people at the top are scared right now. They see the current market and some of the downturn in the economies around the world and in some of the tech, with you see all these layoffs and things like that. They don't want to be stuck without senior people who have knowledge sets, and they don't understand how valuable you are right now. They don't get it. And I'm trying to explain that to people, that you guys have the capability to out-innovate even senior engineers, because you can push forward and break boundaries and barriers. Senior engineers, their cup is already full. They know all the things, and they don't need to bend forward too much. So you guys, you guys, thank you for the likes, you guys. No one realizes how valuable you are. You are the future. You have the capability to exceed the barriers and the boundaries. And I think it makes the most sense. And so, for example, to hire, entry level to build and move forward on that technology. It's really important. I think it's a huge missed opportunity, but it's the people at the top right now. They're scared, you guys. They're scared. They're scared that they're going to lose what they have. So they're currently focusing on senior engineers. I think that is why. That is my answer to you. I think that is currently the market that we're in right now. Yeah, I hope that answers your question. Yeah, I know the feeling. Absolutely. Cromer. And guys, let me tell you, AI can't replace the developers completely in the next 10 years. You got it, that you need to know how things can break and how to fix them. As I know, being a data scientist, but one thing, due to Copilot and many jobs decreased. Yep, you totally got it. Thank you for the likes, you guys. Appreciate it. You are super valuable, and the market is undervaluing. They are undervaluing you right now. You are undervalued. You are absolutely undervalued. Blue, challenges are great. They teach us so much, and that's life. You got it. That's life. You run into challenges, you see what are the problems, and then you can figure out how to fix them. And you try, and you keep trying, and you keep moving forward. XS, AI startups are a bit costly in the beginning because a lot of computation requirements, TPUs, GPUs, how to handle that problem. What is the recommendation? You can do a lot of that work on your own hardware. You don't need to rent computers. And really, the LLMs these days, you don't need to have a super multi-million-dollar budget, right? So what is it, Stanford? What is it, a year or two ago now? They were able to replicate LLM training on just like $600. right? Just $600. And so you can easily buy a computer or just rent some hardware to do that for you if you need that much compute. But you guys, you don't need that much compute to do it today. You can build a business and be successful with artificial intelligence without having to spend a lot. It's become so much more accessible these days, you guys. It is. So there we go. I hope that answers your question. You don't have to spend a lot, XS. You do not have to spend a whole lot. Yeah. Thank you for the likes. All right, let's jump back to our goal for the day. So we're walking through it. We're walking through our code here. So see here. Wait, hold on. One second. Let me delete some of the things. Let me delete some stuff. Let's get rid of that. Okay. I think there we go. So we're only partway through our sleep here. Wait, we got another question. Shyam, you are the good soul. Steven, may you live long and spread the learn and love. Absolutely. Thank you, Shyam. Thank you. I appreciate it. That is the plan. That is the goal. That's what we're doing right now. Exactly as you described it. Here we go, you guys. All right, let's get to our assembly. Let's get onto our assembly language here. Make sure everything looks good. All right, we're looking good. Here we go, you guys. All right, let's keep on keeping on. All right. So here's our assembly. These are things I don't know. Talking about learning, I copied and pasted some of this here. So that's how it goes. I know the move is going to be loading data into a register, or it looks like copying data into a register at this point. Whoa, I just had a brain understanding. Check it out, you guys. Look, X0 is the argument for the function. This is X0. This is like the nanosecond. X0 is the nanosecond because, look over here, if we open up main, then I call it by putting data into X0. Look, you guys, look, right there. Do you see? On line 15, X0 and X0 over here, I've just passed data to a function, right, using BL branch. I don't know what the L stands for. I'm calling a function of some sort. But here, isn't that cool? We just figured it out. We figured it out. It's allocating space on stack. SP is stack pointer. Oh, is it? Oh, STP is stack pointer. Okay. This is good to know. Thank you. I appreciate it. X29 and 30, SP, move the stack pointer to register 29. And then we're doing the same thing here. It looks like we did some swapping of data. Okay. And then here, this part I recognize right here. I understand this part right here, right? So we're saying that we want it to be 500 millisecond sleep. That's the idea. And then we go over here to KQ, which I know is a kernel, or, in this case on Mac, it's kind of like ePoll or a poll, is a way to register events and do event-based exchanges with the operating system and your application. There you go. Oh, no, STP is store part. Oh, pair, store pair. SP is pointer. Oh, is it? Okay. Do we have any SPs? SP. Oh, here we go. Okay, SP. So we see the SPs here on the screen. We see the yellow SPs. And then STP is store pair. It's a store pair. Okay, got it. That makes sense. I understand is SP is pointer. Okay. SP is pointer. Excellent. Good to know. Think we're learning a little bit at a time, you guys. Just learning a little bit at a time. Just a little bit at a time. David Blackgate, good to see you. Welcome in. We're doing some assembly today. Day 3 assembly. Here we go. So I know what KQ is. KQ is like a poll on the system. So let's see. Let's go over here. Open this. It's a sys. We're going to do a syscall to, I guess, register an event for KQ, and the event is going to be accessing, I believe, the system clock is what we're going to do in some way. We need an event to trigger after a set amount of time, then that will interrupt our application to then move forward, and that's kind of how the sleep works. I believe that's how it works. Okay, so we know this is our we're moving data, I believe, from X0 to X20. I do believe that's kind of how it works. So it looks like it goes this direction, doesn't it, you guys? It's kind of doing this direction. It appears to be, I assume, is X20 used again? Yeah, see, X20 is used again down here. So we're moving data from here, there, and this is 500 milliseconds. KQ, all right. So then we're doing move. I understand move ZK. These are different byte levels, so that way you can stack up larger numbers, basically. And so 1 million over nanoseconds. David Black, sorry guys, is there just one assembly or are you more types? I think there are one for each CPU architecture. You're right. So there's like a, David Black, there is like a baseline common language for most assembly languages. Most assembly languages have things like, I believe these things right here, these instructions are common across all assemblies. But there are others that have larger instruction sets, like Intel and AMD. They have super big instruction sets, like the AVX512 or something like that. They have these really big ones that can do multiple steps all at once, but I'm running on ARM, and so I don't have access to this one. I don't have access to this one at all. But you're right. Different architecture CPUs have different things. Thank you for likes, you guys. Appreciate it. Shimon, the Prolog stores the registers on the stacks so you can recover them after the function ends. Oh, really? Really? There's an epilogue down here, but there's a prologue somewhere? Prologue. Okay. Oh, interesting. All right. We're learning a little bit, just a few tips here and there. Every CPU has its own ASM. You got it. Yep, you got it. So we are working on, our build is targeting this architecture right here. ARM64, you guys. We're doing ARM64. Okay. Thank you. Absolutely. Cromer, dude, you can't imagine who you are. You are just acting like a normal guy. I know, but you own the company. I know. I can't imagine. That shows how humble you are. Thank you. Appreciate it. That's a really good compliment. And I think that's you're describing what I'm going for. That's exactly what I'm going for. And I think it's a really good approach because it lets you proceed forward without having to fall back. But also at the same time, I know it seems like I'm humble, but at the same time, if I start bragging about stuff, then I'll feel that pressure. You guys, we were talking earlier about the pressure of the current situation, like that I'm in. Like when you have previous successes, you have the pressure to be successful again in the future. So I'm kind of leaving that out of the conversation a little bit so that I can reduce the pressure. Please forgive me. But it is kind of nice not to have that as much. And so, yes, humble for sure. That is absolutely a part of the picture, Cromer. But also at the same time, I'm just not mentioning it so much. So that way I reduce that pressure. You own a company, B? Yes, I own a company here called PubNub. It is PubNub. We are a communication API company. We let you communicate with every device on the planet. We've got over 1 billion connected devices. And so it's a really cool technology that I built over the last 15 years, you guys. 15 years. It's been a long time. What do you usually come live? Which days? Monday through Friday, sometime during the day. Okay, so I have a lot of meetings throughout the day, and they differ every day. So what we can do is we have a Discord here. I'll paste that so you guys can join in. We got a Discord here. I'll paste that Discord link here. And then you guys can join the Discord, and I will say when we're going live, because I don't know. Every day is different. Every day of the week is different. You feel privileged? All right. That's really cool. I appreciate it. You guys are amazing. I love all the comments that you have. Thank you so much for hanging out with me. We're learning cool things. We're going to keep learning new technologies. We're going to advance our capabilities, and that's like the plan for the stream. We'll talk about various topics. Whatever you guys are interested in, we will definitely jump over to those topics for sure. But yeah, let's get back to the assembly. Here we go. I'll join. Thanks, cool. Thanks, XS. We'll see you there. We'll see you on the Discord. Absolutely. Here we go. One second. Reload what I need to do is figure out what's causing the pause, because we made some upgrades to our subtitles here. We upgraded our subtitles previously on previous live streams because we have this library that I wrote GitHub. Here we go, called Spoken and Twitch OBS subtitles. And this is what it is right here. So we made some updates, and I need to figure out, see, what was it, 2 weeks ago? We made an update 2 weeks ago to our subtitles, and it seems like it has I need to figure out something, because it pauses sometimes. I need to figure out why it pauses sometimes. But you know what? It's fine, because it works most of the time. It works the majority of the time. There you guys go. All right, so let's get back to our assembly here. Here we go. All right, so we're ARM64ing. We got STP, store pointer. which passes data to the pointer, or it exchanges pointers. Moving the data. Okay, so it's part of the stack, and then we got our input. We don't have that. We need to delete that. Okay. Now I'm actually kind of curious. Can we still build? Okay, we can still build. All right, we're good. We didn't break anything. All right, cool. We're good. KQ move. So now this is I remember this. So this is gonna say we need to call KQ, which happens to be this number. I don't know. System KQ is 3612. I'm actually kind of curious. Let's double check that, you guys. Let's go 362. 362. 362. There we go. Is this syskq? All right. One check it. So okay, so it is. That actually is. Check this out, you guys, right here. Look at it is. syskq is this number right here. Whoa, wait, you guys, hold on. Time out. What are we looking at? What is all this? Are all these things the different system calls we can do? Whoa, I know it says deprecated, but syscall, sysexit, sysfork, sysread, syswrite, sysopen and close. No, wait, hold on. Is number 6 close? Wait. Are we using number 6 at the bottom? Do we close? Because it says close. Number 6, right here, look. Number 6. Isn't that cool? We're figuring it out, you guys. We're learning things here. The sysclose call, number 6, right here. Isn't that cool? I think it's cool. And so, wait, there's a syswait? What is that? What is syswait for? I don't know. Look at all these different things we can do. Wow. This is amazing. What about poll? I'm curious. There is a poll. There's a sys poll, but we're using KQ. We're using KQ. KQ is what we're doing. So we're using KQ, syskq, which is 362. 362. This is great. There's K event as well. I wonder, are we using 363 anywhere? 363? We are. Okay, interesting. Okay, so we're using basically KQ here to get our sleep to work. So I know it builds, but does it run? I think I was having some issues earlier. ./main. Is it going to run? So it runs, but it doesn't. There's something broken with it. There's something broken here. Let's keep reading through it. Let's see here. str, move, strh, and a whole bunch of stuff. I don't know what's going on here, but these are adding events. What is W3? I've never seen this. I only seen registers before. I don't know what W3 is. What is W? I don't even know what W is, you guys. But I do recognize this. I do recognize some of these things. So EV add is going to be adding one event. It says one shot, EV one shot. This will be adding one event to KQ, to the operating system that says, I want you to notify me, and where is, based on this data in nanoseconds, which means my understanding is sleep for this long. Sleep for that long. And that's as far as I understand it. Event buster, okay, flags. And now there's just a bunch of stuff I don't know. I don't recognize what this is here. Add, move. I know this closes. We did a sysclose on it. And then this is the syscall. Wait, this, I wonder, is this where it sleeps? Right here. X are 64-bit registers. W is 32-bit registers. Shimon, thank you. Simone, thank you. Excellent. That answers the question. So X is 64 bits and W is 32-bit. That answers the question. All right, we're learning new things. So we've got different kind of registers. We've got 32-bit registers, and we've got X and 64-bit registers. It's the bottom half of X registers. Okay. So then what's the top half? If W is the bottom half, what's the top half of the registers? So we've got W, which is the bottom, which then you only need to use the 32-bit because, you might not need the top half, right? How many registers are there in your Mac? I don't know. How big can it go to? Can it go to X like 1 million? I don't know. Probably not, but there's got to be some sort of limit, I bet you there's some sort of limit. Why should you learn assembly? Abdul, why should you learn assembly? Okay. Because it actually turns out assembly is very similar to some of the languages that you're already used to. So like, for example, we're defining a function here, and this is just like a function in C, right? So you globe sleep, and you've realized that the languages that you're currently working in, like C or Java or Rust or Python or you name it, even JavaScript, they look a lot like assembly. There's like a lot of similarities. You think that, you're working with a high level language, and you are working with a high level language, but guess what? It doesn't have to do a lot of work to compile down to assembly because it's very, very close. So there's some neat things here, and it helps you learn kind of how it gets closer when your compiler compiles to assembly, and then you assemble the language into machine code, and then you link it to the operating system with your linker. It gives you, X to X30 and W to W30. Shimon, thank you. Okay, so we only have 30 registers. That doesn't seem like a lot. That seems like I want more registers. I want more registers than 30. I feel like, Shimon, you're a wizard. You are. Absolutely. Appreciate it. Rewrite Linux from scratch in machine code and binary. Alfie, yeah, exactly. That would be a challenge, wouldn't it? But you could write in an operating system your own RTOS, your own RTOS. Your own RTOS. There it goes. Your real-time operating system. You can do it. It's possible, but you won't cover like all the things that Linux covers. Shimon, thank you for that. 31 general purpose registers on A64. Okay. So 0 to 30, which is 31. Okay. I still feel like I want more registers. I'm like greedy. I know I'm not using all of them, but I feel like I want more. I feel like more is I need. In Golang, yep. So in Golang, it's the same. Yeah, because even with Golang, it could be Cromer. Can you donate me your whole company? I am just blown away, dude. That's why I'm talking nonsense. Yeah, all good. It's totally fine. Actually, I really appreciate it because you figured things out, and I hadn't mentioned them before, but you guys figured it out. And it's actually kind of surprising. It's also exciting too, because when you figure out, that means we get to talk about those things. So if you figure out other things and you find those, definitely we can talk about them as well. How does assembly talk straight to the metal? So assembly is still high level. It's not machine code. You need to run an assembler. So let's look at our build here. Let's look at our build script. So you need to run an assembler, which will take that code, which you saw in our sleep here, which is in our sleep. And then it converts it to machine code. So this convert to machine. Yep, that's what's going on. This converts it to machine code. And this does the same thing too. But then you need to link it. This will link to the object files that you create, which are these .o files, which are machine code. And then it will link those machine files into an executable, a shared executable based on the architecture of your operating system or the target machine hardware that you're currently operating. So that's kind of how that works. It goes compiler, which is like C to assembly, and then it goes assembly to machine code. There you go, like that. So that's kind of how that works. Drawing Brothers, hello, you're here. Drawing Brothers, great to see you. I love this. Will you compile now? Yeah, absolutely. We'll compile now. Yeah. Let's see here. No. Just get rid of those things. Close that. All right. So you just run /build, which is the command to build, and it takes the assembly and turns it into machine code, and then takes the linker and then links the things, and then it makes it work on ARM64, which is the processor. So I can run it right now, but here's the problem, you guys. I'm pretty sure I know what the issue is, but we have to get to it. Nice stream is better than a classroom. Is it, B? So cool. That's great to hear. That's what I want to do, is I want to learn. We're learning together. We're figuring things out. It's exciting, and it's a lot of fun because there's new things that are always popping up, and you run into problems because we're trying it now. We don't know what's really going on, but we'll figure it out. I'm actually kind of curious. Hey, Ali, good to see you. Happy to have you here. Great to see you. There we go. So wait, David Black, are registers memory registers? Can't you just free them and reuse them? Yes. David Black, yes. Abdul, how to start? I'm not able to understand the syntax. Okay, neither did I. So I didn't either. This is day 3 for us, right? We're still figuring out day 3. But if we look, we open up main.s. No, not the actual binary. This is what the machine code looks like, by the way. So if you converted to ASCII, that lets you know that you opened the wrong file. Here we go. Not that one either. That's not the one. This one, here you go. So we've got a data section, and you can define variables. Right? So you can say hello, which is a string, and here's the hello world. So look, this is why assembly is important, because you got the name of the variable, name of var, and then you have the type, and then you have the value. Doesn't this look familiar? If you've done programming before, you've seen typed languages. That's exactly what's happening here. And that's what it looks like in assembly. You would think that, other programming languages would have abstracted this further, but they have not. They're actually pretty low level when it comes to defining data already. Isn't that crazy, you guys? I think that's pretty crazy. Then Rust is also kind of general machine code based on architecture, Stephen. So Rust is a high-level language, and Rust will compile to assembly, and then you can use that to use an assembler to bring it to machine code, and then machine code to your linker, and then you have your binary, and you're good to go. So Rust is still a high-level language in that comparison. It's still a high-level language. Let's see here. How do people make multi-language projects? UTF-8 is called UTF-8. UTF-8. That's what you want to do. UTF-8. Use UTF-8 instead of ASCII. So versus ASCII. So if you use UTF-8, then you're good to go. And that just means that there are specific 8-bit symbols that represent that the next symbol is going to be a higher level symbol, which takes you to extended characters. So that way you can print more characters than just the ASCII base. So UTF-8 is the answer for you. Okay, Stephen, we'll see you tomorrow. We'll sleep today, Saturday here, so free to work 1:30 a.m. That's really late. Thank you for hanging out, Cromer. I appreciate it. RP said, hi. Hey, how's it going, RP? Drawing Brothers, what are you trying to do in assembly today? Okay, so today's goal in assembly is do a sleep and then convert int to string. And so we just walked through our sleep. And so our sleep is over here. So we have our sleep. We put it into a different file because there's just too much going on. So we have this sleep file right here. And it defines a function with one parameter, which is here. Here's the parameter. And that parameter is going to be the length to sleep, how long to sleep for. And I have it building, it works, but it doesn't, I think it's sleeping for too long, and I need to figure out how to shorten the sleep. I'm pretty sure that's what's broken with it, because if we run it, check it out. So see, it's still running. You can see here it's still running. Wait 1 second. I got a message I got to click a button on. 1 second, you guys. I got to click a button. And something comes up every now and then. You got to click a button. All right, here we go. Button, click, done. Okay. All right. If that's machine code, then what are the zeros and ones? That is basically what machine code is. So assembly is like the one step above machine code, right? That's just one step above it. And then machine code is going to be the binary. And then it will look like a whole bunch of ones and zeros. Here's the binary. Here's the machine code. You want to see it? Here, we'll load it. One of these object files. This is what the machine code looks like. Set no wrap, I think. Here. Oh, no. Set wrap. Boom. Here you guys go. This is the machine code. Doesn't this look cool? Look, do you see? There's some, but this isn't. It's reading it as ASCII though. So instead of ones and zeros, it's reading it as ASCII, which is kind of neat because you can see there's a text here. Look, you can see here text. You see that right here? You see the text on the screen? That's part of the. That's where the data. That's where the code is. That's where the code is operating. So you can see here we've got text on the screen. So if that answers your question. Let's see here. Oh, there we go. Text right here. Boom, text. Right there, you guys. Okay, let's see if I missed any of the chat messages, you guys. Only Python has abstracted data type def. If machine code, yep, okay. Did assembly have concept of pointer? It does. We just learned that today as well. We learned that it has a concept of pointer. So that's the machine code, you guys. But the pointer is over here, right here. Let's open up sleep.s. Here we go. SP for pointer, and then STP, I guess, is to store the pointer or to like exchange the pointer. Like that's as far as I understand it. I know there's pointers going on right here. If that answers it. Can you run the code? Yeah, Cromer, I will run the code. So it is running right now. So let's do a build. There's the build, and then we /main, and it runs, but I think the sleep is for too long. I think the sleep is too long. Holy, thanks for the answer. Absolutely. You got it. We are limited to 2 addresses of instructions. I think we have, number of registers? I think you have unlimited addresses. You've got a lot of addresses, or at least the amount of addresses that can fit into memory on the machine, but you only have so many registers. You have 31 registers, 31 64-bit registers, and 31 32-bit registers. That makes sense. I guess 31 because one of the registers is needed for someone else, and someone else needs that register. Instead of having 32 registers, you only get 31. is my guess. I think that's what's happening here, right? I've seen a YouTuber literally use binary to run his IoT device. Really, Drawing Brothers? That is very extreme. Because like if you've got this, I mean, you could. So we could print the binary. Let's see. Do we have like there's like a hex reader? What is? There's a hex dump, and we can do that on like our main. Here we go. So you can do hex dump, and then you can see all the binary. So you can see all the binary here. So you see the addresses and then the output, but it's represented as hex. So you see the binary is hex here, you guys. Simone, STP stores X29 and X30 at the location of SP16. Is the pointer to the top of the stack. Every register takes 8 bytes, so you subtract 16 to allocate space on the stack. Shimon, you know a lot here. You said a whole bunch of things that I understand part of it, but everything you said are words that I recognize, but I need to keep learning more. You're saying cool things, so I do recognize that here. So here we go. STP stores X29 and 30 at the location of SP16. So SP, the pointer of the top of the stack, every register takes 8 bytes. You subtract 16 to allocate space on the stack. Okay. Oh, that's why 16. Interesting. Oh. Okay. I get it a little bit better. Thank you for the likes, you guys. I appreciate it. I'm getting it. We're figuring it out. We're almost there. I think we almost got it. Yep. So you just opcode with addresses and addressing modes, right? I think so. So you've got data and then you've got code execution, and there's different bits that represent what is code and different bits that represent what is data. And when you're running your program, these symbols are recognized in the machine code world. And that's how it differences. That's as far as I know. That's as much information as I've got, you guys. Yeah, I have written assembly in the past. You have Agastronics in the past, but for some ransomware security check passes. Oh, really? So that's some serious work. That's some labor you got there. Drawing Brothers, I think the number of addresses is based on the CPU architecture. Okay, gotcha. Yeah, so that makes sense. The number of addresses, so like 64-bit could have the number of addresses that fits into a 64-bit space. So a lot in that case, right? Was it trillions? Isn't that mean trillions of addresses in the 64-bit architecture? I think that's what that means. Or is it just billion? No, it's got to be maybe billions. I don't know. But it's a lot. It's way more than we need. Okay, here we go. All right, so we're almost done here. So here's where we sleep. And I'm pretty sure my numbers are too big. So I need to reduce these numbers. And this right here, I understand this part is we can't just put into the register a really big number based on my assembler. It doesn't support it. So we have to move Z, K, and K into the X0 register, which we know is the first argument. So X0 is the first argument to the syscall, which is going to be the number of nanoseconds. Isn't that cool? I think that's really cool. So basically, that's like calling the sleep function with the X0 as the first argument, or the first member, or yeah, I guess parameter. I think that's really cool. Use GPT. There you go. Yep, that's the way to do it. Agastronics, you got it. So the assembler just looks up the symbol table and replaces the opcode to its binary. Oh, is that what that does? So it's just a quick find and replace. Blade Z, that's actually really interesting. I didn't know that's how it did it. I didn't know that it was that straightforward. Drawing Brothers, you are using in assembly. So wait, what is in assembly? I'm actually kind of curious. Let's learn that right. In ASM. In ASM assembly. Oh, wait, no. Assembler. Here we go. In ASM is net-wide assembler, an assembler that disassembler for x86 architecture. Well, we're actually using ARM. We're on ARM now, but I think. Thank you for the likes, guys. I appreciate it. Abdul, is all assembly the same? Like C assembly? No, that's actually really good. And Go assembly. So it is different depending on your target architecture. So you've got these high-level languages like C and Go. And then you've got a target assembly output, which is going to be different based on your CPU architecture. So we know here that we are currently targeting, for example, ARM64, but you might be targeting AMD 64, which is like x86, and those will have different instructions. We'll have different instructions that will be compiled down to. That's what the compiler does. The compiler converts your Golang or your C code into assembly, and this is what this is. But we don't have a compiler. We are just playing with the assembly directly, and we're almost there. So I think the problem that I have here, so I'm running it. As you can see, it's still sleeping. It's still sleeping. It's too big. It's too big, so I need to reduce it. So I think I can reduce it by doing that. Let's do ./build, and then we'll do, if it builds success, then we'll do main. Okay, so it succeeds, but it's still taking too long. I'm pretty sure that all I have to do is, thank you for the likes, you guys, appreciate it. Oh, makes sense, cool. Absolutely, Abdul. All right, let's see if we can shrink it further. I think I can just do that. Is that enough? Let's try that. What we should see here is it prints hello world every so often is what we should see. It should be printing hello world. It's still, there's nothing happening. It's a static screen right now. Let's see. I think we need to keep going 0. So let's do that again. Let's do 0, 0. Is that enough? What if we did this? What if we did 0 here? Let's just put everything to 1. Let's just go as far as we can. Let's just go, we'll go 1, 1, 1. Let's see what happens if we do that. Is that good? Okay. It's still not working. It's still, I still don't see anything. So, oh, look, it printed hello world. It printed, but it's taking a really long time. Oh, you guys, look, we did it. We did it. We're doing a syscall right now, and we're doing a syscall. We're registering with KQ, and we're adding an event listener to trigger an event after a set period of time. The kernel will interrupt our program saying, hey, the event triggered, and then it moves on forward, and that's how that works. Maybe if we put that to 0, maybe that's going to be better. So let's see if we can make it go faster. Nope, still pretty slow. Still pretty slow, you guys. Look, it's so cool. We did it. Right there, hello world. You guys see it? You see it on the screen, right? Hello world. It's working. Damn, I know. Isn't that cool? Sorry, BL already link. It works. Yeah, I think you branched the function, but didn't actually call it. Yeah, so BL, I do believe is, I don't know what BL is. I don't know. What is the difference between BL and B? Because we're looping. So we've got a loop here. We've got a loop here, which is a label, right? A label. And then we use B to branch and loop. And so that's what's happening there. Smart people, smart stream. You got it. Yeah, we're getting a lot of help from chat right now. Thank you so much, chat. You're saving the day. You're making things actually work here. We're learning so much today. This is great. You can just do loops using branch and goto. Blade Z, yep. So that's what we're doing. We're using branch here to do a loop. And that's what B is. And then BL, I think, must be for bringing stuff like X0 over. I'm guessing maybe it's like doing a function call is what I'm thinking it is. I think it's like doing a function call. So it's changing scopes and then allowing you to take some of the registers and then do stuff with them. That's it. It's built on top of assembly. C is built on top of assembly. Sorry for my stupid question. Oh, B, good question. Okay, so C is very close to assembly. It is, yes, you're right. The compiler converts your C code into assembly code, which is this, right? This is everything that you're seeing on the screen right now. This is assembly code. So you've got C, and then your compiler compiles that to assembly code, but the compiler needs to know what hardware it's targeting. What's processor? Is it AMD 64? Is it ARM 64? Is it RISC, right? Or is it x86? Is it a different microcontroller of some sort? And so your C code needs to know what kind of assembly to write, and then it will write that assembly. But it also has access to some really advanced operations, depending on your architecture. Your CPU could have some really cool opcodes. You can have some really cool codes that can perform really cool operations, but not every CPU supports them. And so that's why C is really good as the abstraction to be able to write code that's portable to different architectures. I think that's how it works. Isn't that how it works, you guys? Are we saying it the right way? All right, so let me see if I'm catching up with some of the writing the same logic for different architectures. That's insane. We should respect the engineers who created the programming language. You're right. It is it's actually a huge victory that they've helped us so far to be able to do the amazing things that we did today, that we can do today. You got it. BL is for branch and link, so it saves the current address. Oh, it does. Okay. And like the label of the current line before calling it. Okay, gotcha. So it does do some placeholder in. Blade Z, I meant it will run forever, but you can use a counter and the branch conditionally. Oh, really? So you can, got it. Okay, so you can exit, or you can sort of, it knows where to, got it. Okay. So if we do loop, right? So it knows the loop here when we branch, and then we can say escape, like we can exit the loop. We can do that somehow. We can do it conditionally, right? We can exit the loop here conditionally somehow. That's how it works. B, thanks again. Yeah, absolutely. You got it. Hi, John Tonic. John Tonic, good to see you. Welcome back. Welcome into the stream. Happy to have you here. Shimon got it. OMG. Yeah, Shimon is our resident expert for assembly language and other computer things. Shimon, thank you so much for hanging out with us. Husky, how's it going? Hey, good to see you. Beneath, hey, great, doing great. By the way, excellent. Thank you so much for, appreciate it. You're doing great. I appreciate it so much. So we're getting through this, you guys. All right, so we've got some hello worlds, but I want it to print faster. So it's printing slowly. I want it to print faster. So see, there it goes, boom, right there. I want it to take let's try to make it go faster. I think we can do that. So we turned all these to 1. What if we turn that to 0? What if we did that? Is that going to print faster now? I think it's going to print faster. Is it? Nope. It's still slow. It's still slow. Okay. So I think what we got to do is update some of the other ones. Hey, Richie, hey, happy to have you here. We're doing some assembly today, you guys. We're doing assembly day 3. And we've got a loop. So what if we did 1 here and we put this to 0? What if we did that? Is it going to go faster now? Oh, okay. We did it. Okay, perfect. It's a little too fast now. Just a smidgen too fast. All right, let's see if we can make that go. So if we do 1 here, what if we do that? Is it going to go a little bit slower? Nope, still too fast. Okay. What if we did, what if we brought it up here? What if we did something like this? 1 here. All right, so maybe we're figuring it out. Is it? Okay, okay, perfect. This is what I wanted. This is it right here, you guys. We figured it out. Add a 0 before the 1. Yep, you got it, David Black. That's what we're doing. We did it. Okay, so now it's printing at a good cadence. Isn't that cool? So we're calling the operating system to sleep. We're registering an event with KQ. We're adding an event listener. That's a one-time event listener that says interrupt my program when the timer finishes after this number of nanoseconds. Isn't that cool? Drawing Brothers, how can I integrate a small language model with your IoT device, just like Alexa experience? Oh, okay. So Alexa calls out to the internet. Alexa doesn't have a local. Thank you for the likes, you guys. I appreciate it. I like the party poppers. We did it, you guys. We succeeded. We got it to work. We did the system call. We got it to sleep, and we did it all in assembly. Isn't that crazy? You have an HTTP endpoint for your IoT device? Okay, Drawing Brothers, perfect. So you need to host the LLM using GPT OSS is my favorite. So do that here. So you go Ollama GPT-OSS. Here you go. So you're going to do this. You want to do this. You want to use Ollama GPT OSS, and you'll run this locally on your, you have an HTTP endpoint. So if you have this in your house, for example, you've got a server in your house, you'll run one of these. And then you're going to use a voice, also want a text-to-speech model. I think there's a text-to-speech model. There's a good one. There's a speech-to-text. Sorry, I got it the wrong way. Speech-to-text model. There you go. And you want to be able to convert your voice. And so there's some good ones out there. You'll have to find some different ones, but there's some top models out there. And you convert it on your, you convert the speech. So you'll have an audio recorder like your smart speaker. You'll record the audio there. You transmit the audio over to your server. Then you'll translate that to text, and you'll feed that text to the GPT OSS using Ollama with the HTTP endpoint. And you could use Torchlight too. You could totally use Torchlight. Blade Z, that's a really good point. You could use Torchlight as well. You don't need to use Ollama, but you could use Torchlight. Torchlight. There you go. Torchlight. That also works. This works as well. This is a good option as well. Good recommendation, B. Excellent. Or wait, Blade Z. Good recommendation, Blade Z. Man, this is so cool, isn't it? It's amazing. I'm having a lot of fun. So we've got it. We figured it out. We did it, you guys. All right, let me see our clock here. Okay, so we did achieve the goal. That means that we can mess around a little bit more, but we achieved the main goal. And I do have to get going, you guys. I know it has to happen here. It had to happen eventually. We're wrapping up the stream now. We achieved the goal. We made it work. We actually got it to work. It's really cool. And then I suppose so. We basically did it. So this is ARM64 assembly. And this is it. It's really small. It's a really tiny file. And it does something really simple. It prints hello world. We did it, you guys. We achieved the goal. I appreciate it. Thank you guys for the likes. So I don't go live the same time every day, and it differs every day. So what we'll do is, before we leave here, we'll give you a Discord, because I say when I'm going live on the Discord. So we'll copy that and paste it over here to our chat, so that way you guys have it. You can wait. Let me actually copy it. Copy. Drawing Brothers, how is model know your endpoints? Let's see here. Okay, let me paste that real quick. So here, join the Discord, and you'll be able to know when we go live. You could also subscribe, and that works too. How do you know? How is model know your endpoints? So it really depends on what you're trying to do, Drawing Brothers. You need to stack it like this. I'll show you how to stack it really quick. Before we end stream, we're going to answer Drawing Brothers' question. Richie, what kind of specs do you think could run GPT OSS 14 billion? Most machines can run GPT 14 billion, or I guess 20 billion in this case. I guess with the GPT OSS, this is I would say my favorite model to do your localized AI work. But you can run this on most machines. It works pretty well. You only need like 10 gigabytes of RAM or so, or maybe less. Actually, when you quantize it, it's less. So maybe 4 gigabytes of RAM. It's not a lot. And it fits onto most GPUs. Isn't that cool? So, okay, do you need to fine tune it? No, you don't need to fine tune it. You do not need to do any fine tuning. What is your end goal Abdul, what is your end goal to learn this? So with assembly, the end goal was just to mess around. We're just learning. We wanted to do a system call. We don't have time to convert an integer to string today. We ran out of time, you guys. We ran out of time. We'll have to do this on Monday. We'll be back on Monday. Join the Discord or subscribe to know when we go live next. We'll learn how to convert an integer into a string so we can print it. And we'll get one step closer so we can run our application here and have it print numbers instead of just hello world. So that's what we're doing. We're just learning because it's foundational knowledge, which helps us understand how programming languages work, these high-level programming languages. After so many years, you would think that I would have learned this, but we're finally learning it now, you guys. Isn't that cool? Is there a video to explain how to do the same on your machine? For assembly, B. Actually, that's actually a really good question. Richie, okay, that's really cool. Yeah, isn't it? I'm working on my own IoT AI assistant on an ESP32. That's an integrated as a microprocessor that is a pretty popular one, and it's a good price, ESP32, and you can run your own C code in assembly. By learning assembly, you can even try making your own language. You can make your own language, because then you can compile and write that to assembly, and then you can just use the assembly and linkers to build your application after that. So that's exactly how you write your own language. Blade Z, you got it. Okay, Drawing Brothers, if you're still here, we're going to do some drawing. Here we go. Let's clear the canvas. We'll clear the canvas. All right. So here we go. Let's do it. All right. So here is your device. We'll say this is your device with microphone. Microphone. Here's your device with the microphone. Okay. And then we've got, and it's running whatever the hardware is, right? And then you've got your server over here, and then you need to make sure that your device, your smart device, ESP32 or whatever it is, has network connectivity. So that way you can make a server call here, and so that will probably be HTTP call with voice data. And then your server will have, it's going to do a lot of things here. Your server is going to do the heavy working. And this is how Amazon's Echo device, Christopher Smith, hey, how's it going? You caught the end of the stream. We achieved our goal with the assembly language. We achieved it. It works. We did the system call to sleep, and it's running. You can see it right here. It sleeps and it prints hello world, just like that. Isn't it cool? But we did that. We achieved it. We're done, and now we're ending stream. But before we end it, guys, this is the last stream of the week. Before we go today, we're going to help Drawing Brothers with the architecture for recreating a smart speaker, like the Google Home Assistant, or the Echo, the Amazon Echo, like Alexa, for example. Then you can do it like this, exactly like this. I still have use with i2s and the memory buffer for your mic. Okay, cool. So here's your device with your microphone, whatever it is. And you've got your server over here. It's got to be a fairly beefy server because you're going to be building, it's going to be intelligent, right? So you're going to want, I recommend you do it like this. You're going to want to run Ollama server with GPT-OSS, and then you probably do 20 billion, right? 20B. Let's see if you guys can see that. Oh, I hope you guys can see that okay on the screen. I wonder if there's a zoom option, because I'm making some of these pretty small. I wonder if I can. Let's make it bigger. We'll just make the text bigger for you guys. Okay, here we go. Make the text bigger. Text goes bigger. Text bigger. Okay. Device with the microphone is here. And then you got HTTP call to your server, or whatever you want. It could be a TCP call, but I recommend HTTP. And so you've got Ollama running, but you have your, maybe this is like Golang or something, or Go server, or Axum, or some sort of HTTP server. So you've got an HTTP server here running. HTTP server on like port 80. Let's say port 80. This will send the data over to port 80 on port 80. Here you go. And then this server will capture that data. And then you also have, you probably use like Torchlight. Someone's recommending Torchlight. Down left is Zoom. Oh, there's a Zoom. Oh, thank you. Oh, thank you. Look at that. There's the Zoom button right there. I appreciate it. David Black, thank you. We're learning new things every day. Okay, so we got the Zoom there. So you've got, I will definitely use my own hosted model soon. Cool. So this will let you host GPT-OSS 20 billion. I do believe it is 20B, like that. Let's double check. Is it 20 billion? Yeah, 20B. Okay. So you'll run that on your server, and then you'll also run your HTTP server on port 80. And then their HTTP server is going to, will host a speech-to-text model. So it'll be hosting a speech-to-text model. So it's STT, speech-to-text. And then you'll take that audio data, and then you'll put it into the speech-to-text. And then you'll get the text output. And then you take the text output, and you send that over to an HTTP call to Ollama, which is HTTP Ollama. Is on 1143. Here you go. So that runs on 1143. So it'd be like HTTP localhost or localhost colon 1143, and then completion or something like that. And then you post your message, your text message, over to the AI model, and then you'll get the response. And then you get the response. You see, res equals that, and then you can. Then you need a speech to text, because now you want to transmit it back, right, as audio. Then you can get you need your speech or a text to speech model. So you response over there. Send that on to your speech text model, and then you get response audio, right? You get your audio response. So response audio, RSP audio, and then you send that reply back to your microserver. So we'll zoom out here real quick, you guys. Torchlight is for the ESP32 for voice recognition. Wait, are you serious, Blazy? You can use Torchlight on an ESP32? That seems like it's amazing. I didn't know that would fit on an ESP32. Are you serious? I didn't know Torchlight was that minimal. That's amazing. The wake up word. Okay, gotcha. So for the wake word. Okay, that makes sense. Because there's the wake word. I forgot about the wake word. Yep, there you go. And so, let's see, number 5. Here we go. 5. And let me zoom that over here. Let's see. No, number 5. Make that respond back, basically. It's the response back. So that's the reply. And then you did it. That's the response. Okay. That's it. I think that's kind of how it works. Drawing Brothers. That is like just a high level overview, but that should get you most of the way there. Abdul, how to be top 1% programmer. Well, use the AI is pretty good these days, right? You can use the AIs, and here's the deal, Abdul. Even after decades of experience, the AI still was actually really beneficial to me. It taught me a lot. Just working with the AI and having it give me text output for coding, it gave me things that I never even knew were possible. So definitely using the coding AIs will help you a lot along the way. The best thing to do, Abdul, is to build a project. Find a goal. Find an outcome. So you've got this objective, right? You've got this objective over here. Let's see number 2. Here's your objective. You've got your objective, and you're probably standing like right here or so. And this is start, right? Here's your starting point, and you need to get to your objective. And so it's always going to be this is like the simplest diagram. I don't know why I'm drawing this. It's like a really easy diagram to turn. So Abdul, you just have to find your objective. So your objective might be to write a mobile game. So you might be like, let's build a mobile game, right? That might be your objective. And so if you know that's your objective, then you know where to generally start. You might let's use Unity, right? Use Unity to build a mobile game. And then you start from there, and then you start learning Unity in C#, and then you can build a mobile game. Or if you want to build a business and going a step further and you want to build an API company, then that's your goal and that's your starting point. And then you just start moving from there. And then you collect all of your requirements along the way, and then you become top 1%, if that answers your question. Drawing Brothers. Okay, you have to hit URL turn on to turn on the device. URL turn on to turn on the device. I guess at some point you need to have, right, someone was talking about like an activation point. So that also needs to work here. But feel free to take a screenshot or let's pause the video. I guess here you go. It kind of looks like that. So that is just the general architecture. It is missing the activation. So you do need to be listening. And I guess someone mentioned using Torchlight for the ESP32, which I didn't know you could do. I actually still don't know if you can do it, but for voice recognition for the wake word. So your device name, Drawing Brothers, you might use the word brothers or the word drawing, for example. And that will do it. That'll do it for you guys. Okay. We're done. We figured it out. We're ending stream now. Thank you everyone for hanging out today. We'll be back on Monday. Feel free to join the Discord here. I'll paste it again really quick. So for those folks who didn't get it earlier, join the Discord. We will say when we're going live because we don't go live at every time. Or subscribe, you guys. Thank you for hanging out today. Appreciate it. We're leaving. We're actually leaving now. We're really leaving. We're ending the stream. It was a lot of fun to hang out with you guys today. Here is the end button. What? Oh wait, Hatim. What's the project? David Black, thanks, man. Drawing Brothers, thank you. Everyone happy to see you. We're just ending now. Hatim, we were building an assembly project, just learning. We're just learning is what it was. So it was a quick hello world. As you can see here, it's running. It's still running. A hello world that we use a system call to register an event on the system using KQ, a one-shot event to trigger an interrupt on our application and assembly to continue forward. And we did it. We did it, you guys. Thank you for hanging out on the stream. One last question. Okay, we got one last question. We got to get going. One last question. What if I don't have any objective, but I just need high payment job, please? I love that. So you go to ChatGPT. How do I make money? Most money. Minimal effort. How do you do it? We're at this. How do you do it? Okay, so you just have to make one. Abdul, you really just have to make a goal or objective. Just start one. Pick one at random. I recommend game development because game development is one of the more challenging things you can do from a software engineering perspective. It requires you to build efficient code that runs on hardware that's limited to draw a really good user experience. And it requires you to have a lot of patience, but also you learn a lot. So game development. I start with game development, Abdul. Game development is the answer. Build a game, I think. Build a game. Definitely need to catch the streams again. Can't believe you missed another one. Oh, Christopher, no worries. We're headed out now. Good night, bro. Nam, thank you. Nomen King, good to have you here. Good night, guys. Thank you for hanging out. Blade Z, or can just trigger an input by pushing a button. Yeah, you can trigger a button by pushing an input to activate or wake the device. That also works. Got to continue studying for my interview on Monday. Good luck, B. Good luck. All right, guys, we're in it now. Thank you for hanging out. We're ending the stream. We're clicking the goodbye button. Goodbye, everyone. Good luck, and